This is a short demo describing the technical components that have been developed during the first phase of the NGI-DAPC Digital Immunization Passport project. During the course of the project, the team focused on further developing the following three components. Semantic containers are a solution for data mobility. The component has been extended to include a standardized and fully documented API for data exchange, as well as incorporating all of the necessary functions required by participating actors in a single container. The Own Your Data Data Vault is a personal data store that has been extended with an API to enable the aforementioned standardized data exchange. Additionally, the team has implemented digital watermarking for unambiguous tracing of shared data. Finally, the Trusted Digital Assistant, a component developed by the Human Colossus Foundation, is the user interface for credential exchange, which is built upon Hyperledger Aries technology. It also handles multi-language form inputs through the overlays capture architecture. For the first data flow, we demonstrate creating a verifiable credential for a yellow fever vaccination. This requires the user to establish a connection with the doctor, provide the necessary information for onboarding, and the doctor confirming the vaccination has been performed. Here we see the trusted digital assistant of a user. A connection is established by scanning a QR code that has been issued by a clinic. As soon as the connection has been established, the user is able to review the services provided by the clinic. The user fills out the required information and confirms by clicking Apply. The information is transferred to the clinic, shown here on a tablet. The doctor reviews the information provided and confirms the vaccination. Switching back to the user's device, the new verified credential is displayed in the My Documents section. From a data perspective, this workflow has shown a doctor's office receiving data about the user's vaccination request and a verifiable credential being stored in the semantic container. The usage policy from the doctor and the verified proof of the vaccination are held in the user's personal data store. In the second data flow, we demonstrate a customs officer receiving a vaccination credential for the purpose of granting the user entry clearance into a country at the port of entry. This requires the user to establish a connection with the customs officer. The user then reviews the usage policy for border control requirements and provides a verifiable presentation to the officer, who can then verify the information and decide whether or not the user can pass through immigration. Here we see the officer's trusted digital assistant capturing the QR code stored on the user's device. The officer then selects the proof of vaccination credential type from a drop-down list and sends the user a request for the verified credential. Switching back to the user's device, an incoming notification from the officer is received. The user accepts the request and shares the credential with the officer. An incoming auto-filled verifiable presentation from the user is displayed on the officer's side, and the user is granted entry clearance into the country. The user receives two assets. Firstly, a document confirming that they have been granted entry clearance, and secondly, a dedicated verifiable credential which links back to the presentation and the original credential. From a data perspective, this workflow has shown the provision of a verifiable presentation from the user to an officer at a point of entry, and the officer to then be able to issue a credential to either grant or deny entry clearance to the user. The usage policy from the officer and the verifiable credential for entry clearance, including all linked information, are held in the user's personal data store for full traceability. In the final data flow, we demonstrate how individuals can share personal data in a secure and traceable way with other requesting parties. In this flow, we assume that an organization has invited participants to take part in a survey via email. The user can review the invitation request, fill out the survey, and attach time series data from their personal data store. Finally, we show how a user can manage that shared data. Here we see an email sent from a semantic container inviting the user and other participants to take part in a survey. The user clicks the link and connects to a personal data store plugin, which displays an overview of the information. The survey is then auto-filled from previously stored data contained in the user's personal data store. A user can also add time series data to the completed survey. This data is watermarked for the purpose of unambiguous tracing. The user then reviews the data and sends the completed survey to the semantic container of the requesting organization. The user's personal data store also provides a plugin to manage consent information. All consent receipts provided by semantic containers, for example, can be listed along with selectable service endpoints and associated usage policies. From a data perspective, this workflow demonstrates how a requesting organization can benefit from an encapsulated process to retrieve personal data from consenting users while fulfilling all jurisdictional privacy requirements. The usage policy from the organization, a digital fingerprint to identify the shared data payload, and mechanisms to trace data usage and revoke consent are all held in the user's personal data store,